Let's look at the third problem, which is the river crossing problem. Four people need to get across a river. The only way to cross the river is by an old bridge, which can hold two people at a time. It's dark, so people can't cross the bridge without a torch, and they only have one torch. So each player can only walk at the speed of the slower person. They need to get all of them across to the other side as quickly as possible. A is the slowest and takes 10 minutes, B takes 5 minutes, C takes 2 minutes, and D takes a minute. What is the minimum amount of time needed to get them all to the other side? Let's visualize the problem. There's a bridge, there are four people, A, B, C, and D, and we need to get them to the other side. Obviously, there's a lantern. So that's, by the way, there was this game on Miniclip Games. I think why this used to be quite a popular game back in the day, maybe 10 years ago. So it was quite interesting to see this problem again. So let's look at our approach. So our approach is going to be to try and avoid adding the first two times, because we can never have a 10 plus 5, because that probably isn't the optimal approach, because 10 plus 10 is and 5 are the highest amount of time needed to cross the river. So let's say we'd always have to send A and B first, and we're trying to avoid a 10 plus 5 situation. And that being said, let's see after, so using this intuition, let's see who can we send first on the other side of the river, who can we send later. For example, we're going to do something like this. Let's say we're going to send A and C together first. They're going to take 10 minutes, and let's say we're going to send C back. That's going to take another 2 minutes, and then we're going to send B and D on the other side, for example. Selected too many things. Let me put C here. We're going to send B and D on the other side, for example. That's going to take 5. See, there's a 10 plus 5 here. This is what we were trying to avoid. So we probably know that this isn't the right approach, right? Let's go a few steps back. Another approach, let's say, is to send A and B at the beginning. So with this, I was just trying to show you that you shouldn't be sending A and B separately, because you want to have a 10 plus 5 there. The other approach, let's say, is sending A and B to the other side initially. Let's say we send A and B to the right hand side first. It's going to be 10 minutes. Remember, this is what we're trying to avoid, a 10 plus 5 situation. Okay, that's a really bad circle. I'm just going to make something like this. Yeah, a cloud. Okay, so we're trying to avoid the situation 10 plus 5. Send A and B to the one side, and now someone has to get the lantern, and it shouldn't be A, because it'll be a 10 plus 10, which is worse. So it'll be B who's going to go back, and again you see when B goes back, it's again going to be a 10 plus 5 situation, something that we were trying to avoid. So we know that this is also not the right approach. Let's go back again. Oh yeah, let me put the cloud here again. So this is what we're trying to avoid. If not A and B, and we can't send A and B first. So we've seen so far that we can't send A and B first. We can't send A and B separately. So the only other option left is to send C and D first together to the other side. So once we've sent C and D, it's going to be 2 minutes here. So one of them has to go back to give the lantern. Let's choose D for now, because D is faster amongst the two. D. And that's going to be another minute. This just looks like a vector now. Let me put the arrow in the right direction. So now we're going to send A and B to the other side, which is 10 minutes AB. Now someone has to go back, so let me send C back. It's going to be another 2 minutes. And now we're going to send both of them to the right hand side. So this in all is 3, 13, 15, 17. So 17, I'm assuming, is the shortest amount of time. Let's see another way to do the same. Let's say we're going to send A and B first, C and D first, and then instead of D, we're going to send C back this time. This looks something like this, and then we're going to give it to A and B and send them on the other side. This should be pretty much the same thing, because we're just interchanging the order of C and D. This will be a minute, and then 2 minutes when you send both of them to the right hand side. So all in all, everyone's crossed, and again the amount of time that we're getting is 4, 14, 15, 17. 17 is the answer, and I hope the approach is very clear. So if someone has a doubt, you can put them on the comments below, and we can have a discussion.